Hey everyone, so in the last video or in last module we have created a canvas in which we were giving images and we left a predict function if you remember, and we said that हम उस पे एक मॉडर्न प्लगइन कर देंगे और वो मॉडर्न हमारे लिए प्रिडिक्शन करेगा दैट व्हाट दैट इमेज इज और व्हाट दैट पर्टिकुलर नंबर इज. ओके, सो फॉर क्रिएटिंग दैट मॉडर्न एंड बी यूजिंग कोनैब. कोनैब क्यों यूज कर रहा हूँ मैं? क्योंकि वी कैन यूज द GPU विच आर गिवन इन द कोनैब फॉर फ्री, एंड for many of you, you won't have the GPU in your local system. Okay, so I name this model. Okay, so how we will be building this model? We'll use the library PyTorch and the MNIST dataset. Okay, so a little about PyTorch. PyTorch is a very famous data science library which is used to train the models, okay, deep learning models. And MNIST dataset is the digit dataset which has images of digits from 0 to 9. Okay, we'll see at how those are. Okay, so and start with importing the libraries. So first thing, I'll import PyTorch which is imported as torch. उसके बाद जो other features and functions हैं, right, like torch.nl. This is the neural network functionality or features which comes with torch.nl. Optim is the optimizer. So if you heard about, there are many kind of optimizers like Adam, Nadam, Adagrad and so on. So we can use them with the help of this torch.optim. Torch vision we won't need explicitly, but okay, it's okay to import it. Torch vision dot transforms. Okay, so what I'll do, I'll just from torch vision I'll import datasets and transforms. Okay, let me quickly write the code for each of these, and then I'll explain each line to you. So from torch dot nn dot functional, I'll import this. Okay, so I guess now we have everything. So we were here, we don't need torch vision explicitly. So what is datasets? So as I told you, we will be using MNIST dataset, right? And torch vision जो library है, it has a collection of datasets which has many datasets. तो हम ये जो MNIST dataset है, we load from this torch vision datasets. Now this transforms is used to transform the images. Okay, so before sending the images to your training, you need to do certain pre-processing steps. Okay, जैसे trim करना है image को, crop करना है image को, flip करना है, या normalize करना है, standardize करना है, certain so you got the point, right? If you have to do multiple transformations, then this library will come in hand. Then matplotlib, obviously we'll see how images are from this MNIST datasets, where this matplotlib will come up. NumPy, as you know, very handy. And nn.function से हम ये को हम import कर रहे हैं, and we'll see what it does in data parts. Okay. Also, let me just quickly connect to a GPU. You can go here and change runtime type. So here you can access this T4 GPU or V28 GPU, and I'll select, and it will just reconnect. Okay, and till then I'll write the code to check. Okay, this is the exact code. So what I'm doing here, if the CUDA is the GPU, so if the GPU is available, then it will set the device to CUDA, that is GPU, otherwise to our CPU. Okay, and just run this imports, and then I'll check this. Okay, there's something. Okay, here should be from, right? from torch vision, import datasets, and then we run this and we check what device we have. It should be CUDA because we have activated our GPU. So as you can see, we have this device of type CUDA. Fine. Now what I do, we load the image. So before loading the image, you need to do certain, let's say you are loading these data sets and you need to do a certain pre-processing. Okay, there are two ways to do it. First, you load the data, okay, that is download the data in your local system or wherever you are working, and then do these transformations, okay, which I have said, like cropping, fitting, scaling, and so on, right? Another approach is that when you loading the data, you already use that transform whatever way you want to do it, and as you are loading, you do in the process. Okay, so this is where this transform library come in. Okay, so I write this transform is equal to transforms dot compose. Okay, so what this compose thing do, so let's say you want to do certain multiple ट्रांसफॉर्मेशंस, राइट, कि आपको टेंसर में भेजना है, नॉर्मलाइज करना है, क्रॉप करना है. अब एक एक करके भी ये सारे प्री प्रोसेसिंग स्टेप कर सकते हो. और ये जो ट्रांसफॉर्म्स है ये कंपोज फीचर देता है, जहाँ पे एक लिस्ट पास कर दो वट एवर जो भी सारे प्री प्रोसेसिंग स्टेप्स करने हैं, तो ये कंपोज वो सारी प्री प्रोसेसिंग स्टेप एक इमेज पे कर देगा इन यूनिफाइड मैनर. ओके, so I guess we won't need this, we won't be normalizing the images, let's say yeah, so I'll remove this. Instead of normalizing, what we do, I'll create a auto contrast class to use here. तो ऑटो कॉन्ट्रास्ट क्या करेगा, क्योंकि हम यहाँ पे MNIST डेटा सेट यूज कर रहे हैं और वहाँ पर हम कैनवस से इमेजेस यूज करेंगे, तो वील जस्ट सेट सम ऑटो कॉन्ट्रास्ट हियर एंड देयर, ताकि जो कॉन्ट्रास्ट है वो दोनों इमेजेस का वो सेम रहे. ओके, सो फॉर दैट आई विल बी यूजिंग अ लाइब्रेरी कॉल्ड पिलो. ओके, एंड इससे मैं एक इंपोर्ट करूँगा इमेज ऑप्स. ओके, देयर इज ऑल्सो अ फीचर image ops, how interesting that is. So we'll use this image ops and I'll create a class here named auto contrast, okay, or transform. Okay, and I'll use the call feature, so whenever we call this will happen. So यहाँ पे हम इमेज को लोड करेंगे एंड दिस विल बी रिटर्न. तो ये इमेज ऑप्स ऑटो कॉन्ट्रास्ट कर देगा इस इमेज को एंड दैट विल बी रिटर्न एंड विल पुट इट हियर. ओके, ऑटो कॉन्ट्रास्ट एंड दिस शुड बी कैपिटल, राइट, पार्डन. ऑटो contrast transform. Okay, we'll call it, and there is 3s. Okay, so we have our transform, we have our class. Now we'll load the data. Okay, so I'll create one train data set is equal to, and now we'll use our data sets, right? We loaded these data sets from torch vision. So we load datasets dot MNIST. Okay, we store them in the root data. We can give something, but it's fine. We store them in this data library. Train, because we are using the train, loading the train, so train is equal to true, download is equal to true, and transform, so we are putting this transform. So जब भी हम image को load कर रहे होंगे, all these transformations will happen to the image as it is downloading only. Okay, again we'll do this test data set and same thing, only train will be false. Okay, now we'll use train loaders, right? If you remember, we have data loaders, not train loader, sorry, we have imported this data loader. So what is the work of this? So let's say you have a huge data set. Okay, क्योंकि इमेजेस जो हैं दे कैन बी ऑफ वेरी लार्ज साइज. इफ़ यू हैव really good HD quality images, they can go up to 15, 25, 30 MB of each image. And let's say you have thousands of or 10,000s of images, so it is not possible that you fit all those images at once in your memory, right? It will crash your system. So what we do, we take a certain batch. Okay, let's say 64 का batch हमने ले लिया. And now what we do, we at once we take these 64 images, we load them into the memory, and we do whatever pre-processing we want to do, whatever modeling we want to do, and after that we remove those 64 images from our memory and load another 64 images and so on. So इससे क्या होता है कि हमारी मेमोरी पे लोड नहीं आता, एंड हमारी जो रैम है वो हमको कैपेसिटेट नहीं करती कि सिर्फ 64 लेट्स से बहुत बड़ा डेटा है तो और हमारे पास छोटी रैम है तो हम उसको यूज ही नहीं कर सकते. ओके, सो नाउ and be using this data loader to do this. So we'll create two loader. One will be train loader, okay, and we'll use data loader, and dataset I'll put as train dataset. Batch size will be, let's say, 64, right? And suffer is equal to true because for training it's okay to suffer the data. Then we'll create another test loader. Again, dataset is test data, batch size 64, and suffer we have put on false because it is not needed in test to suffer. Okay, let me run this and it should give us our train loader and test loader. So what is happening here, we are loading the data currently. It will take some time, wait for it. Okay, so it has run. So what we do, we'll check. Okay, so let's say images comma labels is equal to next of iter of train loader, not train dataset, train loader. Okay, so what we are doing here, iter will convert this train loader to an iterator. Train loader is already an iterator, but it is just saying to our Python that okay, this is an iterator, and next will give us next batch of the images, that is this batch size. Okay, in this case the first set of batch size, first set batch of images. Okay, so if I run this, we have images. Now if I do this images dot shape and labels dot shape, any guesses what it should be? Okay, let's check. Okay, I should have printed it, or yeah, let me print it, or we can just do this side by side. Yeah, so if you see, images dot shape is 64, 1, 28, 28. So 64 is the batch size, it means there are 64 images. So is the labels, क्योंकि 64 images हैं तो 64 labels हैं. Then there are each image of size 1 cross 28 cross 28. Cause these are black and white images. जो color images होती हैं यहाँ पे 3 होता है for RGB channels, but cause this is just a black and white image, it is 1 cross 28 cross 28. Okay, and there are such 64 images. Okay, so let's see how these images look. Okay, so let's use our matplotlib, and let me create not 10 comma 10, let's take it 12 comma 6 because हमको 5 cross 2 का हम ऐसे बना लेंगे. Okay, so let's plot 10 images for I in range 10. Okay, yeah, this will work. So what is happening, plt dot subplot, हम 2 rows बना रहे हैं, 5 columns each. So each हर एक row में 5 images होंगी, and we are doing this plt dot imso of images of I. What this squeeze function does, as you can see यहाँ पे एक extra dimension है. Each image of the size shape 1 cross 28 cross 28. If I do images of 0 dot shape, dot shape, it will give you this 12828. Now to matplotlib to show us the image, it should be 28 cross 28. So this squeeze will remove this extra dimension, that is 1. Okay, cmap is gray and tighten is okay, 20 dot axis is off. Okay, so we don't need the axis right here because we are just looking for images. Okay, and we should have a tight layout, so that will be fine. And pnt dot show. Okay, it should show us the images here. Cool, right? So if you can see, this is 4, this is 5, this is 8, 5, 8, 1, 6. If we want to see the next set, we can just run this again. So now this train loader will give us the next set of images, next batch of images, and when we do this, we get a fresh image. So as you can see, we are getting fresh images now. So this is 1, this is 5, this is 0. So this is our training data. Okay, what is the next thing? We want to create a model, right? We have gotten our training data, we have pre-processed it, and now we want to create a model जिसमें हम ये training data भेजें and we train that model. Okay, so give me a minute, let me create a model description for you. Okay, so I created this diagram here. We will be following this architecture for our CNN. तो हम images के लिए CNN use करते हैं, and this will be our input image, which is of size 1 cross 28 cross 28. Then we will have our CNN image, CNN layer, which will give us our output of 32 cross 26 cross 26. These are the output dimensions, not the weight dimensions. Then we'll have a pooling, another CNN, another pooling, then one flatten layer for feed forward, and then here our feed forward network will lie, and at the end we'll get 10 logits जिसपे हम softmax लगा के we can get the probabilities for each of the digit. Okay, so let's build it. I create a MNIST classifier class, okay, which will come from nn.module. So if you know how the classes work, whenever we put something here, it means we are inheriting from this nn.module. Okay, and I create a init function, def init. Oh, we don't need all this. We don't need all this. Self is fine, and don't need this, and we don't need this. Okay, so I'll write it again. So we do super, yes, super function, and I write the name of our class, MNIST classifier comma self, and then we do init underscore init. Fine. Now we have to just define these layers: one CNN, two CNN layers, one max pooling, and others. So first convolution layer, and we'll use conv2d. Okay, so now you know where the NN module is used. We can import all these conv1d, 2d, 3d, all other things from this NN module. Okay, so we'll be importing conv2d because we have our 2d images. And first input, because our image has only 1 cross 28 cross 28, so first is 1, so we'll take that. We'll have 32 filters, and we'll take our filter size or kernel size as 3. Fine. Then we'll create a pooling layers and dot pool, and we'll have a max pool 2d. Okay, 2 cross 2 is fine. Then we'll have this second convolution layer. Let me check if the dimension is correct. This will work. We'll, cause this output size here is 32. Here the output is 32 cross 26, so input here should be 32. 64 kernel size 3, and then we'll create 2 feed forward layer. So set dot feed forward layer 1 is equal to nn dot linear. Okay, and this will give us, because there was 64, and if you see the dimensions in image which I figured out for you, it should be 64 cross 5 cross 5 cross 128, and then we'll do this in second. So this is the first 64 cross 5 cross 5, इसको हम 128 यहाँ पे एक वेक्टर latent representation में प्रोजेक्ट कर रहे हैं, and then again from this 128 we are getting into this 10. Fine. Okay, now let me have this forward function, okay, which will take as x or the input or the image, same thing. Okay, so x is equal to send dot pool f dot relu send dot convex. Okay, this will work. So what we are doing here, if you know, our input was x, उसको हमने convolution layer में पास किया, whatever come उसको हमने relu apply किया. So you know now functionality is where they will come. Relu is a non-linearity function, and then हमने उसको pooling पे apply कर दिया. So this CNN layer and then this pooling, जो भी आया वो x है. ओके, उसके बाद उसको हमने यहाँ कन्वोल्यूशन लेयर, सेकंड कन्वोल्यूशन लेयर पे पास किया. अगेन उसको हमने मैक्स रेलू पे पास किया, एंड देन अगेन वी आर डूइंग द पूलिंग. पार्डन मी. ओके, राइट. उसके बाद क्या कर रहे हैं हम सिंपली डूइंग दिस फ्लैटनिंग. सो यहाँ पे हमारे पास दिस 64 क्रॉस 5 क्रॉस 5 था. नाउ वी आर डूइंग दिस फ्लैटनिंग 1 क्रॉस 1600 पे. फाइन. एंड इसके बाद हम अपने जो भी फॉरवर्ड लेयर हैं वो लगा देंगे. ओके, सो फीड फॉर FC1 एंड देन FC2, एंड वी आर रिटर्निंग दिस x. फाइन. सो आवर मॉडल इज रेडी. ओके, एंड मॉडल इज इक्वल टू MNIST classifier. Okay, and we'll pass it to the device. Remember, to device. To device. Okay, so now our model is in the GPU. Fine. Now what we need to do? We need to do training. Correct. We have created the model, but we need to do the training. For that we'll have to a loss function or the criterion. Okay, so because this is a multi level setup, multi class setup, we'll do a cross entropy loss. We'll use a cross entropy loss, and then optimizer. Remember, we have optim this, we have loaded this optim, so we'll use this optim, and we are using Adam here with this 0.001 learning rate, and the model parameters. So whatever parameters we have here, we are passing these here. Okay, so it can optimize them. Okay, now we need to write the training code. So we can train for, let's say, 10 epochs, and for epoch and epochs, range epochs actually. Okay, for epoch and range epochs, for what is the use of I here exactly, I don't know, but if enumerate is there, we can use this. So for I image common labels in enumerate train loader, we are going through this train loader. Images को हम फिर से डिवाइस में भेज रहे हैं, labels को हम फिर से डिवाइस में भेज रहे हैं. Okay, and then we'll do our the training. So first we'll send this outputs to our input to our model, and we can get the output. So we send images, we can get the output. Okay, then we find the loss. Loss is equal to, again we have the real labels, we have our outputs, so we pass them. Then we do this zero grad thing, or we can just do it here only. Okay, so we input it here, and then loss dot backward and optimizer dot step. ओके, सो यहाँ हम क्या कर रहे हैं, हम इमेजेस और लेबल्स को डिवाइस पे भेज रहे हैं. उसके बाद ऑप्टिमाइजर डॉट जीरो ग्रेड क्या होता है, सो ग्रेडियंट जो है ऑप्टिमाइजर में वो एक्यूमुलेट होती रहती है, इफ़ यू नो अबाउट इट. सो वी सिंपली डू दिस जीरो ग्रेड, ताकि जब नया इपॉक चल रहा है तो जो भी हमारी इमेजेस हैं वो फ्री रहें फ्रॉम प्रीवियस ग्रेडियंट्स. Then we are sending this model to our images to our model and getting the outputs. उसके बाद we are getting our loss from this cross entropy labels and outputs. We are doing this loss dot backward, तो यहाँ पे हमारा backward pass चल रहा है, and then we are doing this optimizer dot step. So we are updating our weights, right? We can also connect this loss. तो रनिंग लॉस, यहाँ पे हम एक वेरिएबल क्रिएट कर लेते हैं, रनिंग लॉस, एंड ऑल्सो वी नीड टू सेट दिस मॉडल इन दी ट्रेन मोड. तो पाइटॉर्च मॉडल्स के दो मोड होते हैं, वन इज ट्रेन मोड एंड सेकेंड इज इवैन मोड. सो ट्रेन मोड में क्या होता है कि ये जो ग्रेडियंट्स है वो एक्यूमुलेट होती हैं, एंड और भी कई फंक्शनैलिटीज़ हैं, टेक्निकलिटीज़ हैं जो ट्रेन मोड में और इवैन मोड में डिफरेंस होती हैं. बट जब भी हम ट्रेनिंग कर रहे हैं हमको ट्रेन मोड में होना चाहिए, और जब भी हम इवैल्यूएट या इन्फ्रेंस निकाल रहे हैं तब हमको इवैन मोड में होना चाहिए. ओके, सो वी सिंपली ऐड दिस रनिंग लॉस टू लॉस, एंड कॉज इट विल बी अ आइटम ऑफ टेंसर, सो वी डू दिस लॉस डॉट आइटम हियर, एंड देन विल सिंपली प्रिंट इट कि हर एक ईपॉक में how much loss we are getting. Okay. So yes, epochs, loss, running loss, and length of train load. Okay. This should be fine. So what say, let's run it and see what happens. Okay, it's running. It will take some time. Okay, so it's running. Meanwhile, when it's running, let's write the code to test our model in our test data, right? We have loaded the test data, and as we have discussed, it should be in eval mode. Okay, we'll see that how many are correct predictions and how many are total predictions here, right? तो जब भी हम टेस्ट के उसमें करेंगे, we'll see how many total batches there and how many of these are how many of those are predicted correctly, and we can do the accuracy then. Fine. So with loss dot no grad means कि gradient accumulate नहीं होंगी. Then for images common labels in test loader, that is right, images को हमने डिवाइस में भेज दिया, labels को हमने डिवाइस में भेज दिया, and output is equal to models of images. That is correct. Now what we can do, yes, this will work. So here we are getting this output data, and what we will have probabilities of size shape 10. तो हर एक digit के लिए from 0 to 9 we will have some probability, and we are simply taking the max of it. Okay, and what it will return us, it will return us this, right, the tensor and this. So we need the second part, right? What is the prediction? Returns a name tuple, one value, and second the indices. So value का हमको काम नहीं, we don't need the actual probability, correct? We need the indices, that is it a 0 or a 1 or a 2 or a 3. So that's why first thing is just an underscore and second thing is the predicted. Then we do total, तो जितने भी हमारे labels हैं, and then correct. तो जहाँ पे predicted is equal to labels हैं, वो हम sum कर देंगे and that will be added to correct, and then we'll print our correct divided by total into 100, that is our accuracy. Cool. So let's wait this to run. So as you can see, our model is working. As you can see, the loss is decreasing gradually. From 1.8 it came to 0.5, 0.21, 0.0, and at the end 0.075. We can also drop not if you want. You can just store this loss in a list or somewhere, and then you can not it. Fine. So let's test how our model did in this particular data. Kaboom! We are getting a 99.14 accuracy in our test data, which is quite good. Okay. So now what we need to do, we'll simply just save this model. Okay. So torch.save our model, and we also need a path. Okay, so model dot pt is for models which are saved by PyTorch. This is extension for that. Okay, so we'll save this model and we'll then use this model in our canvas. Should be somewhere here. I download it and then we'll use it in our canvas. Okay, fine. So see you in the next video, where we'll be integrating this model to our canvas, and then we see that how our prediction engine is working. Okay, thank you.